Okay, let's start our seminar. And first of all, I briefly repeat the content of the previous lecture and the basic formula which we will use to solve our problem. First of all, I repeat the basic definition of the ellipse. We have some given point F and straight line A. F and F and straight line A. And the ellipse is the locus of the moving point P, which moves such that the ratio distances to F and straight line A, this one and this one, this ratio, is constant. And this constant is less than 1. This distance is less than this distance. And this ratio is fixed. And the main idea to get the equation of this curve, which defined by this condition, is the following. First step, let's consider some point A which lies on the perpendicular to our fixed straight line. Let's draw this perpendicular and let point K be the base of this perpendicular. This perpendicular FK, and let A the point which lies on this perpendicular such that the ratio of distance FA to AK is E. This constant is called eccentricity of the ellipse. And let's consider the point A prime, which also lies on this perpendicular and defined by the same condition. Both points A and A prime are the points of our curve ellipse. And after them, we consider the middle of the segment A prime, the point O, and we consider the following equation, the following relation between the following segments OA, OK, and OF. Let's fix the distance OA. Let's this distance is equal A. And we fixed OA is equal A, and we fixed distance A prime A, which by definition is equal twice A. Because O, the middle of the segments A prime A. By definition, O A prime is equal OA. And the first step, we consider three segments: OA, OF, and OK. We have the following condition by definition: the ratio AF and AK AF, AK is equal A prime F, A prime K is equal epsilon, is equal E, eccentricity E. And easy to see that the sum AF plus A prime F is equal to A, And by definition, this sum is equal E times AK plus A prime K. Easier to see that OK is equal OA plus AK OK, OA plus AK. And A prime K is equal twice OA plus AK, because twice OA is equal A prime A. Second. And after adding the summation of two values, we obtain the sum to OA plus 2AK, and is equal to OK. And first relation, 2A is equal to OK. We denote OA by little a, and we deduce that the OK is equal the ratio OAE, or ratio AE, the first relation between OK and OA. The second relation between OA and OF. Easy to see that OF is equal difference OA minus FA. FA is equal epsilon now E times AK times AK. Times AK OF. Easy to see, OA is OA FA epsilon AK and we obtain the following OA minus FA AK. OF FA. Okay. And we obtain that OA FA is equal OF F prime FA sorry F to FA to OF I try to obtain the following equality. OF is equal EOA. EOA. OF plus FA, OA minus FA, OA epsilon AK is equal OA minus EAK minus AK. Okay. OA is equal OK, and using the previous equality, we obtain epsilon EOK minus EAK, and OK minus AK is equal OA, and substitute, we obtain the late equality, and we have two steps. And I repeat the reasoning which was done on the previous this lecture. And using this two equality, we deduce the formula for the ellipse. And we consider the some coordinate system which has as x axis the perpendicular to the fixed straight line, or be the origin of this coordinate system, and ordinate axis is a straight line which parallel to our fixed straight line A. And we use the following notation. The points F and F prime are called foci. Our straight line, fixed straight line A, and symmetric straight line L prime are called directrices, and the point A prime we will call vertices. And we obtain the following canonical equation of the ellipse in the following form: x, the ratio x A prime, plus y, the ratio A prime times 1 minus e square is equal 1. And we denote the product A prime times the difference 1 minus e square by b square. And we obtain the following equality: C is equal E times A, and let the coordinate of foci plus minus C0, and B is product A root square minus root square 1 minus e square. And we obtain the sum C square plus B square is equal A square. Easy to see. A. Yes.
What is C0 that you wrote in front of F prime? What did you wrote in front of F prime in the group picture?
Yeah, F prime is a point which symmetric F relatively the region. I'm sorry. I'm sorry. Minus C. Excuse me.
And what is C exactly? Where is C?
C, by definition, the product E and A. By definition, we deduce that the distance OF is equal EOA and EA. We deduce this equality, and this.
How did you write C0? What is the 0?
0. We introduce the sum coordinate system in the following way. We have point F and straight line K. We can draw the perpendicular to our straight line, which passes through point F. The first step, this perpendicular.
Yes.
And we have on this perpendicular some point A, which belongs to our locus, our curve A. And also other point A prime, which also lies on this straight line, 2 points of our curve, A and A prime. And we consider the middle point. of this segment A prime A. And this middle point we call O. And after them, we introduce the coordinate system the following way. The axis OX is this our perpendicular, and axis OY is the straight line which parallel our fixed straight line and pass through the point O. This is our coordinate system. Point O is the origin of introduced coordinate system. Do you understand? And in this coordinate system, F has the coordinate C0, because the distance between F and O, the length of segment OF, is exactly equal C. C, by definition, the product EA. Okay, maybe F EA0 and F prime minus AE0. By definition, this coordinate of these 2 points. We call this point foci. One focus and second focus, F and F prime. F, our fixed point, and L, fixed straight line. F prime is symmetric point, relatively origin, and L prime is a symmetric straight line. We have 2 symmetric points and 2 symmetric straight line. And we also introduce the new notation. Let C, by definition, is equal E times A. B, by definition, is equal product A and root square 1 minus E square. And we obtain that C square plus B square is equal A square. In equivalent way, we obtain B square is equal difference A square minus C square. And we deduce the equation which defined by our locus, our curve, the equation of ellipse. We obtain the following equation: the ratio x square a square plus y square b square is equal 1. The equation of our ellipse. And in this equation we have the following parameter: a from one hand, the A is the coordinate of the point A, point of this point we call vertex, and symmetric point A prime, which also called vertex, and we also to point B and B prime, which has the coordinate B. 0B, and B prime has coordinate 0 minus B. And we can draw the straight line which passes from A prime and parallel our straight line L, and to perpendicular straight line which pass from B prime, and we obtain some rectangle, the basic rectangle of our ellipse. And ellipse ellipse has the following form: is this curve lie into our triangle, and these sides of this triangle are tangent lie to our ellipse, tangent lie in the vertices of our ellipse. And ellipse has the following form: the same shifted circle in the direction of one of the axes. We will suggest that A greater or equal B, and ellipse moving circle in the direction of the y-axis. If in opposite way, if B greater than A, we can change the coordinate axis and obtain this canonical picture when the A greater or equal B. And in this case, we have this conic section which called the ellipse. First problem: let the equation of ellipse is done, and we have the following equation. And we need to calculate the parameters of the ellipse: foci, eccentricity, and directrices. Easy to see that we have the canonical equation of the ellipse. We have the same picture as above drawn. And in this case, we can use these formulas. A is the one parameter. The equation of directrices x is equal plus minus the ratio AE B square is equal the difference A square minus C square, or A square times root square 1 minus E square. For chi F has the coordinate C 0, F prime has coordinate minus C 0, and all. And we have the following equation. The first step, we can write this equation in this form, namely in the form the ratio x square a square plus y square b square is equal 1. How to rewrite this equation in this form? Easy to see. What we can do? We can divide it left and right hand of this equation by the right hand 36, and we obtain the following equation. Easy to see that. And we rewrite this equation in the following canonical form. And easy to see that we obtain the value for A and B. In this equation, we obtain that A is equal 3 and B is equal 2. How to calculate C? You can write this formula in this following form. C squared is equal to difference A squared minus B squared. And if we substitute our values of parameter A and B in this formula, we obtain that the C is equal what? By definition, we have C is equal root square, and we obtain 9 minus 4 is equal 5. We obtain root square 5. C is equal root square 5. And this formula gives us to obtain the value for E. E is equal ratio C, CA. C is equal root square 5, A is equal 3. And we obtain the exact value for eccentricity, the value of the eccentricity. And we obtain almost all parameters which we need to calculate. Namely, we find foci, eccentricity, but we also can obtain the formula for directrices. We have the following formula for directrices. X is equal plus minus the ratio AE. And A is equal 3, eccentricity is equal the ratio root square 5, 3. And then this ratio is equal, in our case, the ratio 9 root square 5. And in our case, we obtain the following picture. This point K has the coordinate the ratio 9 root square 5. A is equal 3, 0. Focus F has coordinate root square 5. These vertices B has coordinate 0, 2. And this symmetric directrix has the equation x is equal minus the ratio 9 root square 5. And the symmetric focus minus root square 5, 0. And we obtain all parameters of our ellipse. This ellipse has the following parameter. F has coordinate A has coordinate 3, 0. K has coordinate eccentricity A directrix. Directrix side. And we have also symmetric point A prime, K prime, F prime, which has the same coordinates with opposite sign. Any question? Do you understand what is ellipse? What is ellipse? We have also other definition for the ellipse, or the theorem for ellipse. Ellipse can be defined as a geometrical locus of the moving point such that the sum distances to the fixed point f and f prime is constant and is equal twice a. Is other definition of the ellipse. Pf plus Pf prime is equal to A. We have the first definition of ellipse and the second. In our case, the second definition is a theorem. But this theorem is equivalent to the original definition, to the initial definition of the ellipse. Any question? Do you understand the solution of this simple task?
Yes, thank you.
Okay, let's continue. This problem only illustrates our previous reasoning. And we can consider a little more complex problem. Problem 2. Given the following condition. Okay. Given the following condition, foci plus minus 3, 0. Eccentricity E is equal the ratio 3, 5. Find the equation of the ellipse. Having the axis on OX, OY. We must to find the canonical equation of the ellipse. And we also use the above mentioned formulas. If we have formulas for foci, we have the value for the C and E. C is equal 3, E is equal the ratio 3, 5. If we can't obtain the canonical equation for the ellipse, the equation is the form x square, the ratio x square a square plus the ratio a square b square is equal 1. We need to find the value of the following two parameters, a and b. How to find these values for a and b? Then we calculate a. A is equal what?
C over E.
Yeah. We have the following relation. C is equal E times A. And A is equal C, the ratio C, E. C is equal 3. E is equal 3, 5. And we obtain that A is equal 5. After them, we can also calculate B. B is equal root square A square minus C square. And we obtain 4, exactly 4, and we obtain the equation for the ellipse. A is equal 5, B is equal 4. How to calculate the equation for directrices? By definition, we have the following equation. X is equal plus minus the ratio A to E. A we calculate is equal 5. E is equal the ratio 3, 5. And we obtain and after them we can easy to draw this ellipse. This point has a coordinate 5, 0, this point 4, 0, this point 3, 0, and this point K has a coordinate the ratio 25, 3. Any question?
Yes. Is there any case that the formula of the ellipse, which is equal to 1, not be equal to 1? For example, x squared over a squared plus y squared over b squared equal to some other number.
This is the so-called canonical equation in the ellipse. And in the canonical equation, we suggest that a greater than b. But if we have arbitrary ellipse in the coordinate system, this ellipse can be other type equation, other equation. For example, if we change the origin of this coordinate system, the equation of the ellipse also change, and we obtain the equation in this form. The equation of the ellipse is shifted origin of coordinate system. We also can multiply this equation and rewrite this equation in the following form. For example, we obtain the equation b square x minus x0 square plus a square y minus y0 square minus a square b square is equal 0. We have also equation of the ellipse, but if we have the equation of ellipse in such form and we need to find foci, directrices, or center, we must transform this equation to the canonical form. First step, we can shift it, the origin of coordinate system, and in the new coordinate system, x prime, which is equal x minus x0, y prime is equal y minus y0, we can write this equation in the following form: b square times x prime square plus a square times y prime square is equal I prime b prime. After dividing on the right hand, we obtain the canonical equation of the ellipse. And we can, using this equation, obtain the exact values for the parameters of ellipse, for the values of the coordinate of the foci, the exact formulas for directrices, and so on. And we can draw the ellipse which has this equation in this following form. We have initial coordinate system x prime, the new coordinate system x0, y0, and in the new coordinate system we can draw this ellipse in this following form. As a rule, we need to transform the initial equation of the sum curve, transform to the canonical form. If we have a canonical form of the equation, easy to find the parameter of ellipse, and easy to draw this firm which has such equation. As a rule, we solve the inverse problem. We have some equation, and we need to transform this equation to the canonical form. After them, easier to see what we obtain after this transformation. If we obtain ellipse, what ellipse we have? What parameter of this ellipse? Do you understand that? Any question?
Yes, thank you.
Mm-hmm. Okay. The problem 3, the same problem when we discussed before. Problem 3. We have the following equation: 2x squared plus 6y squared minus and the question, what's the curve we have in this case? We must transform this equation in the canonical form. Let's write this equation in the following form: 2x squared minus 16x plus 6y squared plus 12y minus 1 is equal 0. We can rewrite the sum of this term in the form of the square of some linear expression plus some constant. Namely, you can rewrite this sum in this form: 2 times the difference x squared minus 8x plus 6y squared plus 2y minus 1. This expression is equal x minus 4 square minus 60. Easy to see. X square minus 8 square plus 16 minus 60. And this equation is equal y plus 1 square minus 1. And after reading transformation, we obtain the following equality: 2 times. Okay.
Shouldn't be 2x minus 4 squared?
Minus. Yes, minus 4 squared. Yes. If this expression is equal x squared minus 8x plus 16 minus 16.
Yes.
And this expression
Okay, I get it. Yes, okay. Thank you.
Do you understand this? This is a standard way to transform this equation in this form. And we obtain the following expression: let's change -1 to 10. So like that. 11. And we obtain that we obtain the following expression. We obtain the following canonical equation of the ellipse. And we can draw the picture and to find the all parameters which define this ellipse. For example, we have that A is equal the ratio 7 root square 6, B is equal the ratio 7, C square is equal A square minus B square is equal and C is equal and easy to see that the eccentricity E is equal the ratio C A and is equal root square the ratio 2, 3 eccentricity. And we have also the exact values for the other parameter. But what's the value of the coordinates of foci F and F prime? We have C is equal the ratio 7 root square 3, but can we calculate the coordinates of the foci? How calculate these coordinates? Easy to see that in canonical coordinate system, the coordinate of foci is equal plus minus this value, the ratio 7 root square 3. But in initial coordinate system, the region of the initial coordinate system, the coordinate of canonical coordinate system in the initial coordinate system is equal 4 minus 1. The coordinate O prime is equal 4 minus 1. But the coordinate for chi in the canonical coordinate system is equal plus minus 7. But in the initial coordinate system, we obtain the following coordinate. We're adding the coordinate of the new origin with coordinate in the, we have the following formula: x prime y prime plus x0 prime y 0 prime. And after them we obtain the following value. Plus for f minus for f prime.
I'm sorry, Professor, I didn't understand the answer. How did you do it?
Okay, I draw the picture and we can understand better. We have the initial coordinate system O, x, O, y. And we have this equation. The point which has a coordinate 4 minus 1, namely this coordinate, 4 minus 1.
For and minus 1 are our initial coordinate system.
This coordinate of the new coordinate system. Let's denote this value by x prime and this value by y prime. X prime is equal x minus 4, y prime is equal y plus 2. The new coordinate system. And we have the following relation. The old coordinate x can be expressed in terms of new by the formula x is equal x prime plus 4, y is equal y prime minus 1. And the origin of the new coordinate system has in the old coordinate system the coordinate 4 minus 1. 4 minus 1. The coordinate of the origin of the new coordinate system in the old coordinate system. Do you understand?
Yes.
Yes. Okay. But in this, oh, I'm sorry. But in this coordinate system, we have the canonical equation of the ellipse. X prime square, the ratio, the a is equal the ratio 7 root square to y, b is equal 7, the ratio 7 root square 6. And in this new coordinate system, we have the value for a7, the ratio 7 root square 2, exactly 5, approximately 5. and root square 6 approximately 3. What we have? We have the basic rectangle of the, oh, I'm sorry. We have the basic rectangle of the ellipse. And we can foci in this new coordinate system. The value foci and we added to this coordinate the coordinate of the origin of the coordinate system, and we obtain the following value for the foci. Do you understand this?
Yes.
Okay. And the same way, we can also obtain the formula for directrices, and so on and so on. The formula for directrices is equal x prime is equal the ratio a in our case is equal 7 root square, and eccentricity and we obtain the following equation: 7 times root square 3 divided 2. And after shifted in the old coordinate system, we obtain the following equation for directrices: plus minus the ratio 7 times 3 to 4 plus 4. We have equation for two directrices. One for the sign plus and second for the sign minus. We have two equations of the directrices. Okay, do you understand that? Any question? Okay. Okay. We have time, and we try to solve third problem. Let's consider the third type of the conic section, so-called hyperbola. The canonical equation of the hyperbola has the following: the ratio x square a square minus y square b square is equal to 0. Canonical equation ellipse is the sum of this term with x square and y square. In the case of the hyperbola, the sign is minus. And in this case, eccentricity is greater than 1. Eccentricity is the ratio c to a, and c is equal to root square for the sum a square and b square. The formulas for directrices are the same. X is equal plus minus the ratio a e, but the draw which illustrated the hyperbola is different. We have to the same point a prime, which has coordinate a0 minus a0, and also we have the coordinate 0b and 0 minus b, and we have the same triangle. But in this case, the relation between A and B can be different. B can be greater than A. C, coordinate of focus, one of the focus, and F prime is other focus, which has coordinates minus c 0. We have also two direct lines, plus minus the ratio b a x. The straight line coincides with diagonals of our rectangle. These straight lines are called asymptotes. And the type of hyperbola is the following. Hyperbola has two branches, and this is easy to see that if y is equal to 0, x is equal plus minus a, and a couldn't be less than a. In this case, we obtain that left side became imaginary, complex imaginary, but not real. And if the point B is not point, the point which coordinates 0b don't belong to the hyperbola, and any point on the axis of y lies without hyperbola, is not belong to the hyperbola. And directrices has a, oh, I'm sorry, directrices this value less than a, and the directrices lies closer to the axis of y. We can illustrate the hyperbola by the following picture. We can use canonical section interpretation. We have the cone. They have some section by the same plane, and we change the slope of this plane, and we obtain, for example, for the small slope, the ellipse, if the slope increase, in this case we obtain parabola, and if we more increase the slope, we obtain two branches, and in this case we obtain the hyperbola. And hyperbola is a third type of the conic section, and which defined by this equation. And we have the following. We have the following task. Sorry, where is? We have the following problem. The last problem. Any question? Find. Yes, yes.
Is hyperbola a part of an ellipse?
About a conic section, about slope.
It's a part of ellipse. Hyperbola is the part of ellipse. Do they have any relation?
The hyperbola and ellipse, the different conic section, and for ellipse we have also various types. If we change the slope, the form ellipse also change. If we have the plane which perpendicular to the axis of the cone, the ellipse became the circle, coincide with circle. If the slope is increasing, form of the ellipse change. We have the more long ellipse And in the limit, when the plane which became parallel to the line which form the cone, in this case we obtain the parabola. Parabola has a different form than ellipse, but only in this limiting case we obtain the parabola. Only when the section, plane section, is parallel of the line which form our cone. If you increase the slope, the plane, in this case the plane parallel to the cone, and we have only one branch of our curve. If slope increase, we obtain other branch, our section, and in this case we obtain the parabola. Exists point of view from this, we have rather one curve than three type. If we consider infinite point of infinity, in this case, these two part of ellipse, of two part of ellipse has some infinity. We have the complementary point infinity, and these two sections became one section, and we obtain the curve which is the same as ellipse. And in the case of parabola, we can also the curve the same of ellipse. But this point of view, the point of view so-called projective geometry. But we, in our course, we cannot consider this point. You finish?
Oh, the last 1 minute.
1 minute.
Oh.
Mm-hmm. Oh, excuse me, I haven't.
You can spend some
Yes, I haven't any time, but the last problem we'll consider next time.